Good evening, good morning, good night even, wherever you are in the world. Welcome to another LIDNUG presentation. For those of you who attended on Tuesday, you'll remember we had Michael Kennedy on doing 18 ways to improve your MVC projects. Well, Michael is back with us tonight, and he's going to be showing us some applied NoSQL in .NET. Just before I hand the reins over to him, there's the obligatory sponsors slide, which most of you have seen umpteen times by now. Please go and visit these guys. Please go and say hello to them, because without them, we wouldn't be able to do what we do. As is usual, you want to get in touch with us. It's info@lidnug.org. It's twitter.com/lidnug, facebook.com/lidnug, youtube.com/lidnug, or bit.ly/lidnug to get you to lidnug.org, which I promise you we are improving. This month we have one more in August. We have Mitch Harper from Winterlect and Programming Inheritance with JavaScript. And then in September, we have Cloudy with a Chance of Data with Josh Lane. Mitch, this is his third event with us, and I've forgotten to change the title on that slide. Oops. He's a technical curriculum director with DevelopMentor. He's Microsoft certified trainer, founder of chatpass.com, and above all, he's a hell of a kick-ass presenter. So without further ado, Michael, it's all yours, my friend.
All right. Thank you very much, and welcome, everybody. I appreciate you coming to this event. We have some really awesome stuff to talk about today. Let me just say I am presenting to you guys while I'm on vacation, and so I don't have my normal office, and if there's any background noise, I apologize. I can't control it as well as normal. That said, let me switch over to my desktop here. All right, so the title of the talk, the title of the presentation is Applied NoSQL in .NET. So what I found a lot of times is, people are super excited about this NoSQL stuff, and we'll talk about what is NoSQL, why do you care, and why should you be excited about it. But what I find is a lot of the presentations are very theoretical. They talk about scalability, they talk about big data, but they don't sit down and actually write a lot of code and show you how it works. Well, that's what this one is about. We're going to write some software from scratch. We're going to set up one of the NoSQL databases and get started with it. So let's go ahead and jump into it. So before we do get into the details, let's look at kind of why do you care about NoSQL. Okay, so we've had pretty much the same data storage mechanism since the 70s, right? We've had these relational databases, and I feel that basically the industry is in a state where if you're going to get started with some software project, people say, okay, well, we're going to have a database, and of course they mean a relational database, and then what? How do we structure our application? Should we have a three-tier approach? Should we use services? Is it a web app? Is it a Windows app? All of these things you might debate. But starting from a relational database is basically an axiom of software development, right? It is, just to really drive that point home, I put the actual definition of axiom here. I chose that word carefully. It's a proposition whose truth is so evident that no reasoning or demonstration of it can make it plainer. It's like you have data, data goes in a database. What's the next question, right? There's no choices here. And I would say that over the last 4 or 5 years, there's been a renaissance of how do we store data, both with the whole cloud systems as well as with, local NoSQL databases. So just, think to yourself, I know we don't have polls or really ways where you give a group feedback, but, when was the last time you consciously thought about alternatives to databases? Right. When we were like, well, we could use SQL Server, but let's not do that. Let's do something else. Right. So in this talk, I'm not trying to convince everybody to just throw away relational databases. That would be crazy. But what I'm hoping to do is show you that this is an actual choice that you make not something that you just, of course, use a database. And maybe the biggest question you might debate as well is it SQL Azure or local SQL, right? That's there's a broader, bigger world out there. So another reason that you care about NoSQL, one of the main reasons I think you care about NoSQL, is many of the most popular NoSQL databases store their data in a kind of a hierarchical way, right? They store them in what are called documents. And these documents are allowed to have kind of structure greater than just rows and columns. And because of that, the shape of our object in memory in our applications in C# or other languages and platforms like Ruby, Python, Node.js, whatever, the shape of our objects almost exactly matches the shape that it's stored in the database. So this whole concept of impedance mismatch and all the problems that you run into with object relational mappers and lazy loading and all the stuff that you have to deal with when you're doing Unity Framework or in Hibernate or something like that, all those problems just vanish. They just essentially do not exist. The shape of your data in memory and the shape of the data in the database is pretty much the same. And a sort of consequence or knock-on effect of this is that your data models become vastly simpler. I'm going to show you an example of a website that I built along with some other guys, and we originally had written it with SQL Server, Unity Framework, and that sort of thing. And then we converted it over because it was just getting unwieldy and it was too much trouble. It was a little too slow. Anyway, we converted it over to NoSQL, and we went from like 100 tables to maybe 150 tables down to 12, 15, something like that. Much, 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 much simpler. So you hear a lot about the performance of NoSQL and the scalability and scale out and big data and all that. Yeah, that's cool, and that's something you do with NoSQL. But what's really awesome, what applies to everybody, regardless whether you've got 10,000 records or 10 billion, is simplicity and easy, simple ways to model your application. So we'll see how that works here. Now, because this is applied NoSQL, not theoretical NoSQL talk, we are going to choose a database. And right now, the most popular NoSQL database that is also a document database is this database called MongoDB. And it's popular because it sort of is a somewhat familiar model. It has some durability, some sort of transactional type behaviors. A lot of the things you do are very similar to the way you would work in, say, SQL or Oracle. But at the same time, it has the simplicity of documents, it has the scalability of certain trade-offs it makes. So we're going to use that, and I think that's largely why it's popular. But I just want to point out that it's only a choice. You guys don't have to choose MongoDB. This is sort of an open your eyes type of presentation. You could choose RavenDB, since most of you are probably .NET folks. This is a very popular one as well. The comparison between popularity of those two, I'd say Mongo is like 10 to 20 times more popular. But you could of course choose RavenDB, and then there's Cassandra, there's Amazon DynamoDB, and just to give you a sense for the spectrum. Amazon DynamoDB is another really interesting one. It's hosted in Amazon Web Services and is a database as a service. What's really crazy about this thing is it's all running on top of SSDs, and you don't buy it in terms of like saying, number of transactions or something like that. The way you pay for it is you say, I want to make sure that all of the queries I'm going to run against this thing, the longest it could possibly take is 10 milliseconds, and here's how much data I have. And so they will give you enough machines and enough scale out so that no query will take more than 10 milliseconds. And you basically pay for the amount of latency you're willing to have. So there's a lot of interesting things you can do out there. The idea is that you can pick whatever you want. There's a whole spectrum. But we're going to pick MongoDB just because we got to start from somewhere, so we'll go with that one. All right. Now, one of the things that people sometimes say is, well, it's all well and good for companies like Foursquare, Facebook, SourceForge, all these sort of techno companies that are maybe on the west coast of the U.S. or something like that, Silicon Valley, that type of thing. it's cool for them to use these crazy NoSQL databases. But look, I work for a insurance company, and we do nothing fast and nothing risky. You know, there's no chance I'm going to be able to use something like a MongoDB or a NoSQL or something. So just to give you an idea here, here's some companies that use MongoDB in production that are not what you might call super, super edgy. Right? They're like real businesses, they do real work, and they need it just to be reliable, right? Intuit, tax financial company, Forbes, Business Insider, SAP, right? The Guardian over in the UK, and things like that. Okay, so here's some, quote, boring companies, or companies that are not about pushing technology, but about pushing their business, that use MongoDB. All right, here's some other more edgy ones, I guess, that also use it. You know, GitHub, Foursquare, CERN, right? The Large Hadron Collider uses MongoDB to collect the data about the collisions as they're doing, you know, work with their particle accelerator. All sorts of cool stuff like that. Okay. So, you know, is NoSQL just for startups and edgy companies? No, it's not. All right, so let's go ahead and get started. Now, I realize I made a minor, let's say, oversight in that I have a MongoDB set up perfectly on my other computer, but because this is a live meeting, it won't run on Windows 8. So I didn't have it set up here. So you guys get to see how we do this. But the cool thing is it takes almost no time. So in order to get started, you would go to mongodb.org, excuse me, and you go to download. Now, I don't know if you've installed SQL Server lately, but it is a tremendous pain. It takes like half an hour, and you know you got to reboot Windows like 4 times, and it complains that you still have to reboot it one more time, even though you didn't realize you had to. Anyway, to get this installed, first of all, it's free. It's open source. Go here and choose the 64-bit greater than 2008 R2 if you have that kind of machine. It has better features than the regular 64-bit version. And it's about 100 megs, so you can download that. And once you download it, it'll be over here in your downloads folder. And so let's just extract it somewhere. All right, so this is about basically installed. So let's go in here, and here's our application. So what we need to do is you can install this as a Windows service, but I'm just going to run it on the command line here. So let's go over to that folder, and we'll just say Mongo D for Damon. Now, if I run this, it's going to start and then it's going to fail. It's going to say the reason it failed is somewhere listed in here. I know the reason, I just can't see where it is here. The /data/db folder doesn't exist. So we either have to give it a particular folder or create a folder for it to store its data. So we can go over here. Oh, it actually is here. This is all well and good. Oh, I take it back. I think I may have this. It's probably already running then. How about that? It is. Okay. So, sorry, I thought I had not set it up, but apparently I did. So you just run a command line to install it as a Windows service, and then it's off and running. Excellent. So that's how you install it, right? It takes a good 30 seconds to install. Super simple. You don't need admin rights to do anything. You just copy that file up there and run it. So once you are there, let's go back over here to my command prompt. Now, there's a host of ways in which you can interact with this thing. I'm going to show you the most foundational or basic, and it may freak you out a little bit. I know it did me as had when I first saw it. So there's a bunch of management tools you can work with, but just to kind of show you the structure and to get you guys started, let's do this. So we'll go over here to the MongoDB tools, and there's a shell. I hesitate to call it a management shell because it's not really, I mean, that's technically what it is, but it's pretty wimpy. And it's just a command prompt. So you can say things like, show me the DBs. And we have this local database. And I can say, use local, show collections. All right, you can do these sorts of operations on it. All right. So this is sort of the basics of talking to the database. You can do things like, we don't have any data in it right now, but I can say db.users.find. I can say, find me all the users where ID databases, JavaScript, equals 7, something like that. I get a sort by first name descending. Okay, so there's this JavaScript API for talking to it. And you may have noticed that JavaScript is starting to take over the world a little bit. And that's absolutely true in the NoSQL document databases. That's how RavenDB works. It's how MongoDB works, and some of the others as well. So the query language is not SQL, but it's kind of a fluent syntax with JavaScript. And what's more interesting is the storage language is actually JSON, or more technically, it's BSON, like binary JSON, JavaScript object notation. And because that's hierarchical, that lets you also store hierarchical things in here. Now, there's some analogies to like the XML stuff you could do in SQL Server, but only very, very little on the surface. In reality, there's quite a big difference. Okay. Namely, you can index inside of these things where you can't very easily with the SQL Server stuff. Okay, we have a question, it seems. Our questions for the final session. Can you talk about RhinoDB, RavenDB, and CouchDB? The one that I can talk to most, I suppose, is RavenDB. So RavenDB is interesting, but I personally like MongoDB better. There's a couple of reasons. You know, RavenDB is cool in that it's written specifically in C# for .NET developers. So if you are a .NET developer, maybe it's kind of the most, closest match to your world, right? There is absolutely a link driver and a C# driver for talking to MongoDB, which we're going to start using shortly. But it's not written in natively in C# or like RavenDB is. It's written in C++. So there's a little bit more of a distance there, but RavenDB is largely based on Lucene, which is a text indexing engine. And so the actual database bits of RavenDB, like the indexing and stuff, is actually using that text indexing engine, and there's sort of some funkiness about sort of eventual consistencies and things that just makes it less easy to work with that you don't run into with MongoDB. So the other ones I can't really speak to. I haven't used them, other than I know that they're they're similar in that they're document databases and stuff like that. Okay, great. So let's keep going. Go back to the slides for a moment. All right, so we have this shell, but of course I'll show you some management tools, some GUI tools that are really nice that we can use in a little bit. So given that we store everything in JSON, that the query language is JavaScript, what kind of funky query language would we use in C#? Well, something like this. From C in context.categories, where name is equal to category name, select C, first or default. Oh, that should look really super familiar to you if you do anything with LINQ, right? I mean, you literally cannot look at this code and tell me whether or not this is talking to a NoSQL database anymore or something like that. Okay, I mean, because unless you know what the type of object context.categories is, you just don't know, right? Which is great because it's very, very similar to what you guys are already familiar with. Converting from like Entity Framework to MongoDB, super easy. Let's see here. Question. In an object-oriented DB, is object-oriented DB a variation on the NoSQL concept, or is it completely different? That's a super interesting question, and it's a good one. Object-oriented databases and, those things came out before the NoSQL stuff and the document databases. And I think what really became a problem for those is they tried to like references back to each other and circular references, and they tried to model like real classes, not just hierarchies of data. And so they're similar. I suppose you would call it a NoSQL database, but I don't think people typically group them together. Let's see, another question. Command line feels like going back in time. Yes, absolutely. But I'll show you some tools that are better. Is there a technical limitation with SQL Server that can prevent it, for example, from running heavy apps like Facebook or Twitter? So I'll definitely post the slides. There's can it do, and there's can it easily do, or is it built to do? These are two different things. So, for example, SQL Server ran MySpace, and I believe they had something like 500 SQL servers or something crazy like that. So, you know, MySpace in its heyday was quite a beast, and it had a ton of traffic. So you could definitely do that with SQL or Oracle or something to that effect. But here's the big difference. These databases give up certain things, like they give up transactions across documents. However, because the documents store, you know, so much data compared to just a row, and working with a single object is transactional, you're not giving up as much as that initially sounds like. But because they give up things like transactions and joins, it makes horizontal scaling vastly easier. So the way that these big companies use these databases is they have like 2,000 small servers running in what's called a sharded configuration. And they automatically sort of balance the data across all 2,000. So when you issue a query to the system, it actually might run on 2,000 machines in parallel and give you the result back. If you're going to do that on SQL Server, that's much, much harder. You've got to basically construct a system whereby you say, well, this, if you know, like all the users whose name starts with A or B go in this SQL Server, all the users whose name starts with C or D goes in that SQL Server, and you've got to keep them in sync. And so a lot of the stuff that you do to make SQL Server work is you have to give up, you know, cross-server, what would be cross-server transactions, cross-server joins, all those sorts of things, and very carefully partition your data. And you sort of fight the thing that SQL Server does, right? Some of its features you have to basically actively, you know, avoid using and manually do a lot of the other stuff that makes it simple. Whereas here, it's just part of the system. So yeah, you got it. So I think the question is, can we push this till later? You're more interested in the technical details of how to use NoSQL. Yeah, you're great. So that's great. So we'll get to. I guess I'm done. So yeah, we'll move on. How's that? But hopefully that answered your question. All right. So let's go and get started. Now what I want to do is, instead of starting from a pre-built app, I wanted to start from just a file new project, okay? Because I want to kind of show you guys simple stuff here. Let's go with the web, that's fine. Okay, first NoSQL web. All right, so let's start with a internet, that's fine. Start with an internet application. And what we're going to do is we're going to first get a hold of the drivers we need. Drivers are the equivalent of what in Microsoft SQL speak would be the provider, right? The library, the DLLs that actually allow you to talk to the server. So give it just a moment here. Now, if you've worked with Entity Framework code first, where you actually write the classes, and then you create a class who has iQueryable properties that represent the tables, and then you just start working with it, you'll see that that stuff really came out of trying to model data in the same way that they already do in the NoSQL databases. So that should be very familiar. But if not, here we go. So what we're going to do is we're going to go to NuGet. And we could start by, first of all, let's just type Mongo. Wait a moment. All right. So typically you would start with the official MongoDB C# driver. That's pretty cool. But what I would want to start with is an open source library built on top of that called sort of an optimistic concurrency system that also provides some sort of foundational classes to get started. So this, you can see, depends on this Mongo C# driver. That's the official driver. So I'll install both of those off NuGet. So it's going to download those. The terms are really simple and no big deal. Okay, so let's go ahead and just to keep things simple, I'm just going to create a make it really obvious. I'm going to create a Mongo folder, which normally you wouldn't do this, but just to make it clear, like here's where the classes for this thing go. I'm I'm going to create a class. Now, what I need is I need the equivalent of the object context or the data context that you would get in Entity Framework. And both in Entity Framework code first, and here we have to create our own classes. So I'll call this MongoDB data context. Let's call it that. And we'll create, this will derive from, is it Kennedy, Mongo dot, what did I use for the namespace here? MongoDB.Kennedy, that's it, DB Kennedy dot concurrent data context. Okay, so it says now we need to implement a constructor because there's no default constructor. So we're going to pass these things in, and it's going to leave it like that. So we could override the server name or the port name, but it's required that we say the database name because who knows what your database wants to be called. All right. We could also, for this one, set it to be just equal to call it the LIDNUG DB, all right, for our presentation here. Okay, so and it just passes off to the base, which we're not going to allow you to override the safe mode. Now what we need to do is we need to create some properties here of iQueryable of something. So let's suppose we're going to model something like a bookstore or something like that. So let's suppose we're going to have some books. So we need to have a class. Whoops, if I could drive my mouse better. Book. So we have a class called book. In order to use it in this system, we have to implement a certain interface, which we'll get to in a moment. But let's just give it some properties. Let's have the string title. It's going to have a property of type, which is a floating point, which is a price. Okay. And we are going to have a property of type date time when this is created. Let's go ahead and create a constructor. So we can say created equals datetime.now. Okay. And let's also give it a, while we're here, a list of string. Let's give it a list of comments. And this comment class doesn't exist. So let me create that really quick as well. And we'll just say that this has a string. Property. These ought to be properties, not fields, by the way. Text. Okay, and datetime created. Let's also do our little trick here. Created equals datetime.now. So I'm sure I'll forget to set it at some point. Okay, so here's a very simple object. These can get way more complicated. You know, we could have lists of comments which have a list of other things and so on. One other thing, just for not when it comes back from the database, but when we first create it, just to keep our life a little simpler so we don't have to check if comments is nulls, let's always initialize it to something like this. Okay, so suppose I want to save this and query this back from the database. So I'm going to come over here and say I have an iQueryable of book, and that's going to be called books. Now, this is not settable. What I need to do is I'll say return this dot get collection of book as queryable. Okay? So it's pretty simple implementation. And let's just suppose we want to work with books, but you could do this for publishers, users, etc. Right? We could just keep going. Of course, we'd have to have new classes, publisher, book, user, and so on. All right, so you would, for all the top-level objects, you would do this. Now, I can come over here to my home controller, and let's see. Let's just go ahead and run it and see where we are. We should have a basic website that just starts up. So what we're going to need, basically, is we're going to need a way to create there we go. We need a way to create a book, and then maybe this section will show us all the books that we have. So we're going to need two pages. This home page we can use to show them, but we're also going to need like an admin. So let's add that page really quick. So let's go here and just have something that's called create book. Create book, okay. And we do it like that. Now, if you guys saw the previous presentation about forms, you'll see that we are going to have an input form here. So we'll have a get and a post, and we'll take a book. Okay? And we'll do something like save book, return, redirect, home. Okay, here we want to show some sort of view that will let us edit a book. And so let's just say book equals new book. That's the one we're going to start from. So if there's any defaults, like the created days today, things like that, we'll show that in our form. So just take a really quick diversion here and just go and create this. Actually, let me make sure it compiles first, because that lets the tooling so easier. Let's go and say create a new view. And we're going to go down here and say book, like that. And we're going to say this is going to be a create. It's great. Okay, so we're going to have our title, our price, our created, and so on. And we've got a submit button. So the only thing we need to do is go to our index.cshtml. Actually, sorry, our layout. And over here in our little bit, we need to have some new nav. Say new book. This will be create book on the home controller. So let's go over here and look at this real quick. Okay, so we can click new book. Here we can hit the title is some book. The price will be $2.99, and the created, we could make that read only, so we don't have to mess with that. But we'll just leave it alone, right? We're not really too concerned about the UI. So we hit create. It should go back to the home page. Now the thing we want to do is we want to, of course, save it, and then we want to show the list here. So let's go ahead and try to show the list first. Let's go to our home controller again. Now we can start doing some of our link stuff. So I'll come over here and say MongoDB data context. Context equals new one of those. Let's make that public. Okay, so throughout my controller, I'll be able to access my database using this class. So it's very, like I said, any framework code first style. So for this thing, let's just say var, I'll make it more explicit, book array books equals, now here's the tricky part for you guys, from B in context.books, where, let's just say, order by B dot title, descending, whatever, select B. And then we'll just call to array. So if you guys have done anything with link, this should be completely familiar to you. So let's go over to our view really quick and just show off the items. So we'll go over here and we'll say at model, lowercase model, is that. And down in this section, I'll just change this to books. I'll just say at for each tab, var b in model. We'll put a little div, we'll say title, colon. This is going to be really ugly because we're not taking the time to fix it. BR, as you can see. When you have BRs, you're probably already doing it wrong. Price is going to be at b dot price dot toString in, let's just say C2. And created at b dot, whoops, created to long date string. Okay, and finally, we'll say comment count, just for now. We'll deal with comments in a little bit. At b dot comments dot length count. Semicolons not needed. All right, so let's run this again. We'll see all the books in our database, which is, of course, not too many. So right now, there's no books. I see there's a question I'll get to in a second. However, it didn't crash. That already should be kind of interesting to you. It didn't crash because we we went and talked to the database. If this was SQL, it would say, you know, cannot log in or authenticate to database called LIDNUG DB or whatever we called it, right? But it didn't. And actually, if we go over to our, you know, in pretty strong quotes, our management system, I can say show DBs, not shows DBs, show DBs, and oh, there's now an empty LIDNUG DB. So by simply accessing the system, it's started to say, oh, you want a LIDNUG DB? Great, got that taken care of for you. But there's no data in it. So let's go and look at how we might do something to put data into this database. So we come over here, and after I do this, I'll answer your question that's there. So here we create the book, we save the properties. We would, of course, add validation attributes, verify that it's valid. But let's just assume that everything is good, just for the sake of speed here, so we don't waste time. We're going to say, assume book is valid, or whatever. And we probably use a view model and all those things. But let's just do this. We'll say context.save book. Okay, that's it. Now, there's one little caveat here. It says it must be convertible to iMongo entity. And that's a very, very simple class. But let's go and make sure this implements iMongo entity. And to implement this, let's use ReSharper because it looks less ugly. We just need two properties. One is for Mongo and one is for the concurrent library, concurrency, optimistic concurrency stuff. This is for Mongo. So all the objects in MongoDB have this identity, which by default is called _ID. We could also call it a capital ID, and it would infer that it maps over to this _ID on the server as well. And by default, it's this thing called an object ID, which is very, very similar to a .NET GUID. Although, if you want to not generate it from the database, not make it auto-generated, but generate it yourself, this could be a string, this could be an integer, it could be whatever. But to keep things simple, we're going to let the database auto-generate it. And this is only for internal use, so don't worry about it. Now, let's look at the question really quick. How do you handle the equivalent of a lookup table? For example, if you need to select from a list of genres, where would you get the genre list? Great. So that's a great question. There's two possibilities here. Get rid of the question, yes. So one thing I could do is you're asking about if I have a public string genre or whatever. Here, I could, I don't know why getting set is red, but anyway. Oh, I do know why, actually. There we go. I could actually have an array, or maybe it's simpler to work with is a list of string of genres. And I could just store that right on the book. Okay. So that would end up with data duplication, potentially. So like 3 books are in the sci-fi category. Well, the word sci-fi shows up in 3 places. That may or may not be a problem. You can do indexed subqueries on these things. So you could say something like, show me all the books where genre contains sci-fi, or something to that effect, or give me all the distinct items and all the genres across everything. You know, those are things you can do using an index crazy, crazy fast. So it might not be a problem, but it is a data, you kind of, if you're going to rename sci-fi, you got to go across all the books and do it. The other possibility is this could be an object ID, which apparently I hit insert, genres, and then this could store the IDs to a separate, not table, they're called collections in MongoDB, but basically a table. So you could sort of do this foreign key constraint. In that case, it's not enforced, in which case that can be a little sketchy. So you got to be a little safer with your code in C# to make sure you're doing things right. Okay, so hopefully that answers the question. Next, how would you enhance your model support multiple author entities? I would do it probably the way on line 20 I have it written now. I would just have like a list of object IDs, and I'd probably have an authors table, and just add the IDs in there, and then do a second lookup. Give me all the authors whose ID is in this genre or author set, something to that effect. So It's not really an in-one plus query, but it would take sort of 2 queries to get all the information back if you really cared about them in that case. Okay? All right, but let's go save some books. Remember, to bring us back to what we were doing, we went over here and we wrote, home controller, we wrote this code that said save book and said you have to implement this ID, which is fine. And, you know, before I call save, ID is going to be empty, but after I call save, ID will be set, kind of like Entity Framework and auto-incrementing integers, that sort of thing. But let's go do that. Here. So let's go add a new book. So this will be Fun with Live Meeting. This will be $2.99. Can't sell that one for much, I'm sure. If we hit create, all of a sudden, ooh, look at that, we have a book. And apparently I forgot some BRs. Let me do just a little better formatting so you guys can see this. Go ahead and make this strong as well. This is some pretty hideous HTML, but you'll get the idea, right? Fun with Live Meeting. Let's add another book. Support manual. Manual for live recording. This one is more pricey. Let's create. All right. So check this out. I didn't go to the database and say, oh, create a table called books. But guess what? Now my database is not empty. I can say use LIDNUG DB. Be careful, this is case sensitive. Show collections. There's a book, so I can say db.book.find. And let's look at it like this. Pretty. Who wouldn't want their data to be pretty? So here's the data we put in there. Here's our auto-incrementing ID or a GUID-like thing. Here's our access ID. Don't worry about that. Title, price stored as a double, the date, and here's an array of comments, which is an object. So just for time's sake, I don't want to go and write a form where I can edit comments or whatever. So let me do this. Let's go over here and just say the next one I create, add some comments rather than write a form, blah, blah, blah. Okay, so we'll say book.comments.add a new comment, and what I'm going to say here, we'll say text equals this book is killer. This one goes, didn't love it, but useful. Let's add one more. Read this one again. All right, so let's go create another book. But notice, to work with the sub-documents, it's identical to just give me the object property and add in another sub-object, right? This is how you do it in C#. You'll see this is also how it manifests in the database. So let's create one more book. Say this time with comments, and this one is going to be just $1 or whatever unit of price it is. So there's that. Let's go and pretty print that again. Check this out. So this last one is the one we just inserted. So we've got these documents. And this is hard to overstate how much this simplifies your database. So instead of having a book table and a comment table and a comment to book table and a whole bunch of other sorts of things like that, I have just a book collection. And if I want to get it back, I don't have to worry about lazy loading because you know what? I get the whole document back, or I put the whole document in all at one shot. You can do projections, but if you ask for the book, it automatically comes with the comments. It's not actually a join in the database across multiple tables. It's literally find one thing by its primary key and pull it back. Super fast, super simple, really neat. All right, so I see I now have 4 questions. Can MongoDB be embedded like RavenDB? No. That is one really cool thing that RavenDB does that MongoDB doesn't. I don't know that they have plans to do that. All right. Sorry. I wish it would be possible as well. Are there any NoSQL databases that have a GUI manager? Let's go get something. Let's see if I have it, actually. No. Okay. So, like I said, I kind of didn't set this up because I sort of mentally had the thought that, oh, this is all installed. But anyway, we do this really quick. So RoboMongo is one of your options. Probably the best. There are other possibilities as well, but RoboMongo is killer. So here's your GUI. Let me go and download this, and we'll check out our app. It should take almost no time to set up. So let me install that really quick. I'll get it installing, and then I'll answer the next question. All right, run. Yeah, sorry I have to install this. I should have it running, but you guys can see the whole end-to-end process. Okay, so let's go and just connect. So I'll call this local machine, localhost, whatever, connected. You can do authentication. You can also misspell machine. So here's our databases. You can go and say, show me the stats for the size and all that. It sort of pre-allocates some files. You can say, open a shell, where I did things like db dot, oh, look, IntelliSense. That's already good. Dot find, dot, let's say, sort by title :-1. So if I run that, you just press F5. You can see this time. So it's sort of your GUI management thing. You have some different views. You have that view as well. Be careful; it's always limits to 50. So you gotta go through there. So there's a bunch of cool stuff you can do here. See, all right, 8 questions, excellent. So there's at least 7 different other ones. There's a link in the slides, but let's say MongoDB GUI Kennedy. There's a blog post, hopefully that will find it. Yep, there you go. So there's a roundup of MongoDB management tools. There's a whole bunch with the price, what platforms they're supported on, how to use them, et cetera, et cetera. So check that out. The answer is yes. Does this mean that foreign keys are not in Mongo? Yes. One of the big trade-offs it makes is it says the thing that kills horizontal scalability. The reason I can't go to SQL Server and say, let me just put SQL Server on 2,000 small little cheap computers and scale it horizontally is because the foreign key constraints might have to cross the database. Similarly for joins, similarly for cross-database transactions, all that. So there are no foreign key enforced in Mongo. But if you have stuff that is within a document, there's an absolutely strong relationship. This is enforced that there's no way to have this comment detached from this book, right? So it's the whole entity modeling becomes extremely important and is something you have to be careful with, right? So you have, this is basically a foreign key constraint, more or less, right, between comment and book. Right, you would have to model it that way in SQL Server. And even though there's no foreign key here, this is how it works. So hopefully that makes sense. So it's less relational, not non-relational. How would I add a comment to an existing book? Oh, okay, great question. So let me go to this one where we're going through our books. And let's just add a comment to each one of them. For each our book, we'll say book.comments.add. New comment added at plus date time dot now dot to short time string. Now we got to save our book. Oh, whoops. Hold on. New comment text equals. That's to do, right? Like that. Okay, so here we've added it, and then I just say ctx.save book. So these are the existing books, right? I got it from the database through link, and then I make changes to them however you want. I could change their title. Let's do that to book.title equals book.title.to upper, right? Just to show you that we're making changes to lots of places and adding a comment. Now if I run this again, you should see all of them have this. Their comment count is 1. If I refresh it, the comment count should be 2. Go back over here and we rerun this. Say edit. You can see these have these new comments. Make sense? It's just like in any framework. Do a line query, change it, call save. The only difference is you call save for the object. It doesn't do change tracking. Okay. If I change the structure document later, what happens to the previous entities in here? Okay, so that gets a little tricky because there's no schema that's actually enforced. So you basically have to run an update script, or you can go over here to this book class, and you can do things like you can say bson ignore extra elements, and then just load it and save it, and basically that would drop them off and change the shape. But more likely you're going to need to run an update script like you would need to in SQL. Okay, Next question. Yes. Okay. Next question. Is object ID treated as a primary key in the table? Yes, and it's indexed. And it's very important that you create your own indexes as well. So there's a whole profiling system. You can say, show me all the queries I'm running that are slow. And they treat anything slower than 20 milliseconds as totally slow, and it needs to be flagged for improvement, which tells you something about the mentality of the database, right? So you can create all sorts of indexes, and I think you should do that. But by default, underscore ID is a primary key, and there's an index on it always. Let's see. Next. Does that mean anything, add anything to a document, you need the whole document first? Yes, so that's a great question. If you're going to use link to get the database, to get the object, then you get the whole thing back and you change it and you save it. But that's not the only way to do it. I could have written code that wasn't link. I could have said over here, I could have written some code. I could create an update statement and say, I want to push this new comment onto the collection, onto the comments collection for the book with ID, whatever its ID is. And that would not retrieve the object from the database. It would just push the comment down and modify it on the server. And it would do so in like a transactional safe way. So that's a really important point. Let's go back to the next question. So if comments are part of the book, in this case, if I have customers and address is changed, how is the case that address changes will be updated for all existing customers with an existing address? So it depends. Do customers share addresses? If they don't share addresses, then you just go and change it maybe as a sub-object on the customer. If a customer might have a separate address, well, then you need to write in a statement to say, find everybody who has this address and change it. Right? You can query deeply into these objects using indexes, so it's just as fast as if it was a separate table. Okay? You just might update more than one record. Good. Is there a concept of computed columns? Not really, but there is a MapReduce framework and an aggregation framework that will let you sort of do the computation, spread across all the servers, and return the result. So not exactly, but sort of. Peter. So looking at that pretty up in the CLI command line interface, does it mean that the data is actually stored in MongoDB as JSON? Yes. Technically, it's stored as BSON, which is the binary representation, so it doesn't have to parse text, and it's more compact and whatnot. But yeah, this is effectively the actual shape in the database, although it's binary rather than text, which is mind-blowing to some degree. But it's also how RavenDB does it. Okay. Jose. Can you use the same comment among a few books? Yes, and there's two ways to do it. Either you just insert it into both of them, have data duplication, or you do what I was talking about over here with the authors and the genres, where you have a comment table, and this would represent the ID of the comment. So like a non-enforced foreign key constraint, right? But for comments, I don't think that makes sense. For other things, it may. Okay. Next. Do I need to create index for performance reasons? Yes, yes, and absolutely yes. You need to create, it's the biggest thing you can do. If we have some extra time, which I don't think we will, I could show you that, but yeah. Is there an equivalent to store procedures or there a more effective way to run expensive queries? There are almost no expensive queries in the system if you use your indexes right, but yes, there actually is the concept of a store procedure, and you can either have, get ready for it, JavaScript functions stored on the server. If you go over here, you can actually see, I believe, functions here. Add a function. Here's your JavaScript. Boom. Or you can use the MapReduce aggregation framework. Either way, it's kind of, it runs on the server. You could also add a navigation property using those IDs. Okay, interesting. Thanks. Let's see. Just for those of you guys who are wondering what this is. Yep. So there's definitely some framework that can be built on top of this. All right. Okay, can you store images? Absolutely. There's two ways to store images. One way to store an image would be as if our book byte array image data. There's one, right? Just stash the data on there as a byte array. The other is there's an entire sort of distributed file system that like shards out as well. So I could say this. I could say context.db.gridfs.upload and give it a file stream, like a memory stream or other file, and then say download that back. And that will actually store it as a separate blob in a separate collection, not quite as stored on your object. So if you sometimes want the book back, but you don't always need the image, you're probably better off saving it somewhere else. If you typically want the image when you get the book, just store it on the book. There is a limit to the size of these documents. Each document here can only be 16 megabytes. So if it's bigger than that, you probably want to store your blobs separately. Okay. Can you call those functions from .NET code? Yes, you can call them. You would just basically issue like a run command on the driver. Okay. Similarly, a little bit like you can with an Unity framework, but they actually have the functions themselves. What happens if you install Mongo on a shared host? You can set up security. There's user accounts, permissions, that sort of thing. So you could run it in an authenticated mode so they don't get to it. What I would do is if I was on a shared host, I would use something like Object or Rocket, something like that, which is a MongoDB as a service. These guys are pretty awesome. For $29 a month, you get for pure, look at that, $29 a month for pure SSD shards. Shards are like how you split them across, right? So if you go look at pricing, not too bad for a gig. Okay. Anyway, that's probably what I would do on a shared host rather than. So the DB runs some kind of JavaScript engine like V8, Chakra. Yes, absolutely. I don't know what the JavaScript engine is. Actually, I don't know if it's V8 or not, but yes, that's absolutely correct. Okay, so hopefully, let me just recap. This gives you guys a good sense of how to work with this database. You quote install it by unzipping it, and then you run a single command to install it as a Windows service. I'll show you. There's like we have an online class from DevelopMentor that shows you, that sort of gets you started. And actually, there's like a 2 or 3 minute walkthrough on how to set it up as a Windows service or a daemon on OS 10. So you download and unzip it and basically register it as a system service with like a single command line, and then it's up and running. Then you simply address the database, and it comes into existence. Like you saw, I tried to query on the LIDNUG DB, and it's just boom, now we have a LIDNUG DB. I tried to insert something, or I just inserted something into a book, and then bam, we have a book collection in here. Okay, so you just work with this. It's very similar to the way that Code First, Unity Framework Code First works without all the horrible pain of migrations. Unity Framework Code First is awesome the first time, and then it gets grosser and grosser as it calcifies this object relational impedance mismatch. This doesn't have that problem to the same degree, right? Okay, so you just work with it. Let's see over here. We create these classes, give them properties. These properties can be like primary types, fundamental types, or they can be like lists of other objects and forms this tree. And as long as it has an ID on it, you can save and load it from the database. We do our query via link. Let's say we could say, where b.price is greater than 5, right? So if I run this, again, we should have 3 books, not 4, theoretically, or 1. Forgot what I put for my prices. All right, but you can see it's filtering out only the expensive books. Okay, so we do our link statement, get our books back. If you want to make a change, you edit the object, call save, or you do this more complicated but better performing sort of push, update sort of thing. And to create one, you just new it up, make the changes, and save that insert. The reason save versus update is it looks at that ID and goes, is the ID empty? That means insert. Is the ID not something? Let's go update something with that value. Okay. All right. So, see, I got a few more questions. Can you perform backups? Absolutely, you can perform backups. It's so much easier than SQL Server. CD, where's my folder? It's got to get. If I had this in my path, do I? Nope. I would put this in my path if this were my real machine. I would say this: Mongo. What is it? Backup. Hold on. Mongo dump. Mongo dump. There you go. Backed up. So you give it the command line arguments, and you basically, it gives you this, okay? And then to restore that, I would just say later on. So let me go over here and say, like this. Let's say drop this collection, yes. So you can see refresh, there's no collection. So I'd come over here and I would say cd dump, cd, I would say // Mongo, how many dots do I need? Mongo restore, -- drop. Well, I guess you wouldn't need that, but you would still normally say that. Drop, -- db is LIDNUG DB. Actually, let's do it this way. Mongo restore, -- drop, that means start from fresh. DB is LIDNUG DB. Then you just give it the path, which is here. Let me put my quotes correctly. There you go. And now it's restored. Let's see, refresh. Oh, it's back. Okay, so yeah, backups are super, super easy. How can it handle GIS data? Can it handle, I don't, great question, especially given what you were just talking about earlier. I don't know if you can natively just stash it in there, but there absolutely is like 2D, 3D, find me all the objects near this, right? So you can do like index queries around location and all that kind of stuff. So there is geolocation in there, I just haven't done much with it. How about users on MongoDB? DB roles? Yes, you can totally do that. You can, as of 2.4, which is now out, you can do users, you can give them read access, write access. There's like 7 or 8 roles that you can put them into. Yeah. Okay. How do you perform a delete on an individual book? Do you remove all the lists? Yeah, no, so if I wanted to delete a book, I would just go over here, instead of saying save, I'd say ctx.delete book, and it would just use the primary key to delete it. I'm not going to do that, though. That would wipe out our database. That would make our demo less fun. Okay. How does Mongo compare with storage for Azure? Can Mongo be used in Azure? Yes. In fact, MongoDB is the only NoSQL database that you can use on Azure, like by default, I believe. MongoDB Azure. So I know the Azure guys did some work with the MongoDB guys. I was actually at MongoDB headquarters in New York City a while ago, and one of the guys from Microsoft who helped get this stuff all working in Azure was there as well. So yeah, it's definitely supported. You can get it going in Azure. I haven't done it because I'm not using Azure, but yeah. MongoLab is a free tier. Yes, that's awesome, and works great with Azure. Yeah. So MongoLab, Object Rocket, those are 2 of the big hosters, that's for sure. Yep. Okay. JS data, you should at least be able to use binary and show for image. Yeah, I'm sure that you can do that. But I don't know if you can do an indexed query on it, right? Whereas if you store it in its like the right format, it will actually let you say, find me all the objects less than a quarter mile away from here or something. Okay, I love the questions. Keep them coming. Is there a good way to replicate the data back to SQL Server for reporting services? Not super, super, super automatic easy, but I don't see why you couldn't also create an entity framework model that looked like the model you have, and then just do like an auto mapper, copy over, save sort of thing. So it's easy enough to model the same basic thing in any framework, and if you just set up an auto map type of thing, you'd probably be good. Okay. What about triggers? Not really. I mean, you do have the functions and you have the aggregation framework, but not really triggers. Schedule jobs. I would just schedule a job to, like a batch file or something to call a function on the server and just use the Windows scheduler for that. DTS, not that I know of, although you do have the ability to replicate a set of servers to another one and set them up what's called a replica pair, or connect one in a master-slave style, and it will like just constantly stay in sync. So that's good for like geo-located, like replicating across like data centers and stuff. If I need to learn NoSQL MongoDB, where do I start, please? Okay, that's cool. Let me address that. So all of this stuff came out of our online trading platform for DevelopMentor. And I'm working on a class here for, like this is all running on MongoDB. I'll give you a little background on it as well, but here you all can go do this. It's for, you can do the first task for free and preview it. There's only one thing right now to try, so basically it means it's effectively free. I'll post this for you, but just go to learninglineapp.com. And then just find the MongoDB class. So this class takes you through like how to set it up as a service, what are the management tools, all that kind of thing. A lot of things we covered here. So definitely check that out. Is there a way converting SQL Server schema into the equivalent? Well, not exactly, but you can use Entity Framework to make the transition pretty easy. Let's see. When I save an object, it appears on all servers immediately. Well, it depends if you're doing one server or multiple ones, but if you have multiple servers in what's called a replica set, it depends on how you set up the connection to the server. So suppose you have 3 servers involved in it. You can say, do not allow me to return from this query until it has been committed to all 3 servers, in which case it effectively, the concept of eventual consistency, it sort of goes out the window. Right? It is consistent as far as you're concerned. You say write, and it doesn't tell you it's written until it's written to them all. All right, you mentioned a size restriction on per document. Is there a way to check the current size of a document? I don't know, actually, but it's going to crash. I don't think it's going to save partial data. It'll say, this is too big or something like that. So that's for sure. So while we're here, let me show you something that just to sort of drive home the point of how this will simplify your life vastly. Okay, so here's like a lesson on our online platform, and this is one of the things that drove us to switch off SQL Server. So we had something like 15 tables we had to query in order to load this page, right? And it would take it's way more complicated than it seems like it should be, but anyway, that's maybe a different debate to be having. But there's a lot of stuff going on here, and it was slow, it was hard to evolve over time, and so on. And when we switched this over to Mongo, the performance just went through the roof, the simplification, it was super, super simple. So let me switch over and actually show you a picture from the slides here. All right, so here's how this actually looked for all the tables involved to show a task. We had favorites, you could favorite the activities, you could vote on them, which are like the little learning pieces, you have tags, you have users, who's reviewed it, like there's tons of stuff here. That's super complicated, and this is simplified. Here's how you might model this with MongoDB. This is how we model it with MongoDB. You have a task, the task is an array of tags, as an array of activities. Activities have a type, they have sub-properties, right? So there's still a decent number of classes involved, but the top level objects, there's only task, user, and completion, these 3 gray areas. And if you actually look at what would be a fair comparison to SQL Server, there it is. Instead of this, I'll give it a minute for the screen to refresh. Instead of this, super complicated, look at all those pointy lines, right? This is crazy. Like if I want to delete an activity, well, what else do I have to cascade that delete to? It's not pretty. That, well, I can tell you how to do that. That's simple. So this, to me, actually is the biggest reason to use NoSQL on a document database, is the simplification you get is crazy. Now, we were having some of our queries take like 200 milliseconds, 250 milliseconds, which is not super, super slow, but it doesn't scale all that well. Once we switched over to Mongo, those same pages are down, the data access part of them are down to 2 milliseconds. Almost every query we can run on the entire system is sub 2 milliseconds, definitely sub 10 milliseconds on a single server. Okay, so very, very nice. All right, so a few things that you want to be aware of. I guess really only two I want to hit on, given the time we have, because we need to wrap it up. Make sure you use the 64-bit version. So if you're over here, MongoDB, here, don't run it on 32-bit. The reason is, you see these little warnings here, is the way it sort of interacts with memory and the file system is the 32-bit ones have a 2 gigabyte file limit. There's plenty of these guys that hold like terabytes of data. Okay, so use 64-bit, and then this thing wants lots of RAM, so give it to it. All right, so let's see. All right, I do have one more question, then we'll do a conclusion here. Is there a storage limit on the database size? So the way it works, basically, there's no storage limit unless you use the 32-bit. It doubles the size of the file and pre-allocates it from like 16 megs to 32 megs up to 2 gigs, and then it just adds 2 gigs chunks. If you want to look at something interesting, if you go to mongodb.org here, and you go home, look at scrolling down. If you go look at production users, there's some really interesting ones, Craigslist, Firebase. Here's another hoster that's good, MongoHQ. But if you look for WordNick, these guys wrote a whole bunch of blog posts which are really interesting for this. It says they store their entire corpus in MongoDB, which is 3.5 terabytes of data and 20 billion records. The speed to query the corpus was cut by a quarter the time it took previously before they migrated to Mongo. All right. I know Facebook acquired a company that does a ton of stuff with it. There's a bunch of companies that have a crazy amount of data. Like Foursquare just runs on MongoDB, right? They may use MySQL in there somewhere or something, but their main data, I believe, is on MongoDB. All right. So another question, if I can control my mouse. No, that's the same one. Okay. So switch over here. All right. So here's the takeaway from this. Your database is a choice. It should not be an axiom that you have data and it goes into a relational database. There's a whole bunch of interesting choices, of which MongoDB is probably at the top 3. You should think about what is right for your project. And I think you'll find that once people get over the shock of just something different, that these document databases are actually pretty appropriate for many, many, many types of applications. Not all of them, but many of them. Okay. NoSQL doesn't mean non-relational. It means it means less relational, right? Like in my book example, there's a very, very concrete, solid relationship between book and comments, but not across books, or not across a book and an author if we just have a link to it. So less transactional. Document databases are definitely the most prominent type of NoSQL databases. There's other ones like Azure Table Storage and things like that, but document databases are where it's at. And the reason is because the horizontal scalability you get, the simplicity that I just showed you with that going from like 15 tables down to 1, as well as performance. Okay, and link is awesome, but it's not the only way to talk to it, right? There's certain types of things you might want to do that just like push a new comment onto a record without actually pulling it back, as we talked about. Okay, so here's that class I was telling you about. If you guys want to go check it out, you can do it for free. So you don't need like a coupon or anything to log in. Just create a free account and go check it out. And with that, I'll open up to questions. I know you guys have been asking like crazy, which is awesome. But if you have more, keep them coming.
Well, we still have 15 minutes yet.
Oh, do we? Okay, fantastic.
Yeah.
I was thinking we were done at 11. I was running over, so let's see. What else is it that I would like to show you? Let's talk about indexes, because that really matters. Do I have enough data that I can do anything interesting? Probably not. But I'll show you how to do some indexes anyway. So let's suppose I want to find the book with ID. Let's not do ID because I got to do a big ugly good thing. Let's say price. And this query language is a little annoying that you got to learn something new, but it's pretty simple. Let's just say this is $sign greater than say 2.0. All right, so we're going to run this, and this finds all the objects that have the price greater than 2. I suspect this is probably hard to see over live meeting, this little text, so I'm sorry, I'm not trying to zoom that really. So maybe you want to know, well, is this using an index or not? So you can say explain on it and say F5, and you'll see right here, basic cursor. If you see basic cursor, you need to go, whoa, this is the problem. In fact, we could go and do this. We could say over here, we could say db dot get profiling status and run that, and it says 0 and slow is 100 milliseconds. Let's say this. Let's say set profiling status 1 and 5. Oh, level, sorry. There you go. All right. So what we're saying is this is, okay, it's turned on, and we are treating queries that take longer than 5 milliseconds. Let's turn this into 1. Maybe I can get something to show up here. Okay, so in that case, now we have these turned on. Let's go to our little app here. I'll go run some stuff. Dun, dun, dun. This. Let's run a few things. Let's go create some books. Another, oh, that's kind of crazy. Another book. 1255. Go create that. And we got our 2 books. Now we've done a little work with our server. We can go and ask it a question. I can say, just keep another shell open. I can say db.system.profile. Whoops. Profile.find. Let's just do that for now. Ah, nothing. Let's see if I can set the profiling level higher to just verbose. Do this one more time. New book. Be slow. All right, so basically what that's telling you is no query I've done yet takes more than 1 millisecond or 5 or whatever it was that I put in there, which is pretty awesome. Okay. Ooh, awesome. So I found one. So here you go. We can go and turn this on, and it'll say, well, how long did this take? Okay, 0 milliseconds. Fantastic. We want to speed up. But imagine this were slow. What I would do is I would come over here and say, all right, well, first of all, what query is it slow? And the easiest way to see that is open it up and says, okay, well, the price greater than 5. That's my link expression translated over to JavaScript. So let's take this, the query value with the curlies, come over here, and let's go back to our shell. Let's put this in, all right? And we'll say, okay, you said that was slow. Explain why that is. Oh, I see. That's using a basic cursor. That is a problem. So what I want to do is I want to add an index on price. So we'll go over here and we'll say, open another shell. We'll say db.book.insureIndex. Then you just express the properties. And it could be compound or not. Take your pick. We'll say price, colon, and you want it sorted naturally by ascending or descending. All right, so we'll say 1. And now I'll come back to my find statement that was previously, quote, slow. I don't know if, it really wasn't actually slow, but imagine it were. Now you run it and you can see, oh, B-tree cursor price 1. So that means this is now using an index. Okay, so what we had to do to make sure all of our queries on Learning Line were sub 10 millisecond, sub 2 millisecond on my local machine was basically turn on profiling, set it at the limit we want. I started out at 10 milliseconds or 20 milliseconds, and then I just ran it and watched this thing pile up over here, this system thing. And I can say things like let's say a dot sort millisecond -1. Okay, so show me the slowest queries first. All right, here's one that took 4 milliseconds. Okay, so it was just looking at indexes. It's not super interesting. But here was look up a book, and it took 2 milliseconds. Wait, no, sorry, 0. Still the slowest. But here's an order by, and we're ordering by title. Here's a query for price. So we also probably need this sort by title. Right, so we were just going through and sort of working on each one of these. So I say, all right, well, we got this one down to use a cursor, but what if I were to do, sorry, a B tree, which means index. So what if I were to do a sort by title, ascending doesn't matter. Well, that's back to a cursor. So let's go and add a title index. So we'll say title, rerun that. We'll go back over here. Now we rerun this. We're back to another index. So we just did this until we can run our site, and there's nothing showing up in our log that is a query that takes more than 10 milliseconds. Right?
We've got some more questions there, Michael.
Cool. Can you flesh out an example using a separate table for genres and books? Yeah, no problem. Let me do that next. Let me see if I can address some of these questions quick. Does the performance improve if you use multiple collections in place of multiple documents? No. Indexes. Basically, you have to have indexes. The performance typically improves the more stuff, the less spread out it is. So rather than having like a comments table and a book table and their relationship, if you have books which have comments, that's definitely going to improve performance. Thanks, Alexis. Appreciate it. How do you handle transactions or distributed transactions? There are no transactions. That's one of the trade-offs you make so you get simple horizontal scalability. Other than if I go to this book and I change its comments using the update statement rather than link, so 17 people could all be updating this collection at the same time, and that would be transactional. But spanning documents is not transactional. Updating one document is, provided you do it right. How much does indexing slow down inserts? It does slow them down, but I wouldn't worry about it. You know, the more indexes you have, the slower inserts are going to be, because unlike Raven, it computes them before it saves it in, right? You're not going to like get partially out of sync stale indexes. So don't have indexes you're not using, I guess. But I showed you how to figure out what you are using, so there you go. Could use a decimal value instead of place for doubles. Ooh, that's interesting. Let's see. Big number. Okay, let's see if I can save some and what happens. I actually don't know the answer to this question, so we're about to find out. By the way, that change I just made is just going to evolve the schema, and it's going to be all well and good. So let's go back here. Big number, 1. Great, thanks a lot. Okay, so that's interesting. So see here how it's saving this as a price, as a numerical value in JavaScript, in JSON. It will do it, but it will save it as a string and then parse it back. All right, so for example, sorting by it would be a problem, but storing it apparently is not a problem. You're not going to lose an A per accuracy or something, I don't believe. Okay, excellent. Keep them coming. Let me see if I can make this break loose. Excellent. Okay. Can I find this video later? Yes, it'll be posted on the LIDNUG YouTube channel.
Yeah, I'll answer that one. Yeah, it'll be on our YouTube page, usually within 24 hours of this ending.
Yeah, so Vlad, great question. If there's no transactions and you need to update more than one table, how do you handle it? So what I would say to you is try to have your documents set up in a way so that you don't do that very often. 2, set up a rollback mechanism if something goes wrong. I mean, that's really the trade-off you have to make. Okay, when backing up the database, does it impact availability or performance? Availability, absolutely not. Performance, not really. We back up our learning line database every 4 hours, I believe, and I think it takes like 2 seconds, 3 seconds. We've got like 2 gigs of data or so, and it doesn't really affect it now. A little bit, but not a ton, because the backup is quick enough. It definitely doesn't take it offline. Okay, would you consider using it for a local storage app, like a cache? And if so, is it possible to secure the database? You could use an encrypted file store like BitLocker and save the data to that folder to secure it. I would possibly, I don't know, I would probably use an embedded database or something. If you're like installing this with a WPF app. But some people do use it for caching on top of regular databases. Can you give an example of an aggregated function? Boy, it's kind of hard to set up. I can show you. Example MongoDB, but just given the time we have, it's not relevant. It's not worth it. So you would write something like this. Given this table, aggregate, group things by the state, and then match where these things, where you pull off the sum of the population for each of them, and then you match it where the total population of the state is. So here's a way to aggregate, like go find me all the zip code areas where you have like people that live in a zip code and stuff. Find me all the ones for the state. Turn that into the population and then sum them up. Okay, that kind of stuff. Can I find the presentation PowerPoint afterwards? I will put the PowerPoint into the notes. I just can't do it while I'm presenting, so I'll do that right after. Let's see, this one I addressed. So how do you link SQLDB data to a NoSQL data? I would write Entity Framework code that pulls it out of one. It has a similar schema to what you want in NoSQL and copied over. So isn't having too many indexes going to hurt performance? Yes, absolutely. So don't have more indexes than you need. But, do you insert more than you read? It's really a matter of, like, what do you do more of? And what do you want to be fast and what do you want to be slow? No transactions. What about exceptions? So if you try to insert something and it fails, that's just going to stop that operation, right? So you're not going to partially insert something if the insert failed. It would actually just not insert it. But you can't do that, say, like a cross-reference. I can't insert 20 books, have the third one fail, and not have inserted the first 2. Okay, let's see. So you're saying there won't be locking problems if 2 or more people try to access or amend the same document. Well, there'll be serialization issues where it slows you down. You can all read them in parallel, but writing to them will slow it down. But that's the same way it is in SQL right now, right? But if you access 2 documents, then you'll be okay. Many thanks. Perfect answers. You're very welcome. Yeah, Hadoop is also definitely interesting, but it's a little different. So thanks for coming. Appreciate it. So a way to do bulk upload. Yeah, there's a bulk upload option. I didn't use it in the example, but there is one. Can this be linked to a native code? Oh, yeah. In fact, .NET came after C++ in terms of what's supported here. Let me see. Docs. So there's the ecosystem. This is what you want. Drivers and libraries. So here's what you can talk to it with. C, C++, C#, Erlang, Java, JavaScript, Node.js, Perl, Python, PHP, Ruby, Scala, some other stuff. Okay, so absolutely. Okay, and Denny, let's do that example really quick with authors. So let me just do this. Let me just cram in here one time. So one time create authors. Well, let's just do this. We'll say context.authors. Authors dot add. We're going to need a new author class here, so let's say author A. IntelliSense equals new author, and this will be Ted. So let's create this class here. Great. And let's go down here and duplicate this. Authors, and make sure this is author here. Okay. Add. Oh, sorry. Got saved. Too much in the framework world. New, I'll just say A here. So that'll save them. And then let's say for each book here, we'll say dot, we don't have our authors, I'll add that in a minute, dot add a dot, we need an underscore ID, okay? Let's do that before we save here. Okay, so first of all, we need to make this implement. I'm Mongo entity. Looks like this. And let's give it a property called string author name. Let's give it a constructor that takes a string name and say author name. Let's initialize that. Okay. And this also needs to be public. Ooh, as well as does this. Okay, so there's our author, right? We should be able to save them, but our class doesn't have. Let's go over here and say authors. And also do this for authors. Author. Oh, whoops, sorry. Object ID. There we go. Okay. So then, that's how we would do that. If we wanted to actually get the authors back, so you might say, well, how do we get the authors? It's a little bit cumbersome the way I have this set up if I want to like show them. So you kind of have to, look the other way. You have to look the other way when I write this code. I didn't write this. This wasn't me. So hold on. Let's put this up here. Because what I really want to do is create a view model that has the author and the book associated or something like that, right? But let's just do this. Just because I only have, I'm already 4 minutes over. So let's say for our authors equals context.authors.where A goes to b.authors.contains a.id, okay? .toArray. Does that make sense? Hopefully. And here I'll say for each var A and authors. Let's say div author at a.author name. Make sense? Let's compile it and see if it works. So every author should have at least one, and every time I run it, this should get another author, basically. Let's see if this runs or crashes. All right, author. Perfect. Author Ted. If I run it again, I should have Ted. Ted. You can see them adding in. Does that make sense? So now our author table should have 1, 2, 3, 4, 5 Teds. And let's go over here and say refresh. We have an author table which has 5 Teds. Author name, because I just hard-coded it in, but you can see different object IDs. Barely, but on the end it differs. And if I go to my book, we've got our authors. Go down here, and there's your basically your foreign key constraint. Okay, Denny? Cool? Hope so. Store confidential info in SQL and non-confidential in NoSQL. How would they work together? You could totally do that. You do have, like I said, access control and all those kinds of things around NoSQL. So you're welcome. Thank you, Denny. You can do it. I think what I would end up doing, it's not super awesome, but if I was doing .NET, I would probably use Entity Framework to talk to the SQL bit, and MongoDB to talk to the other, and maybe use like a repository later that kind of hides that, hopefully. That would not be too horrible. And those of you guys who said good presentation, thank you very much. Appreciate that. So I think that's pretty much it. So.
Yes, definitely, Michael, definitely. Yeah, I mean, we don't mind running over occasionally. It happens, you know.
Yeah, sure. All right.
But yeah, absolutely, another great session.
Thanks. Hopefully people can find some good stuff, and I encourage you to go check out the.
Well, I'm actually going to go and have a play.
Awesome. That's awesome.
I've looked at Mongo and I've thought maybe sometime, but you've piqued my interest now.
It's really, I think, the best of the document databases.
Well, just to give you an example, I'm actually a Postgres person.
Oh, okay, awesome.
I'm a big Postgres aficionado, and yeah, I can see some elements of Postgres in the design of Mongo. You know, I can see where they picked some of the great ideas up, and it's absolutely astounding. You know, but thanks again. I can't remember off the top of my head when you're coming again with us next, but I sincerely hope you are.
I hope so. If we don't have something scheduled, just talk to me. We'll figure something out. And
off camera sometime, I definitely want to talk to you about the GIS side of things, because I've got some absolutely awesome ideas here.
Okay, that's fantastic. Yeah, let's do it. We can talk on Skype or something. Let me really quickly upload these slides for those of you who are left, and if you want, you could just make it available to everyone who's no longer here. Let me go
for it. That's not a problem.
Got to download it locally, apparently.
Just while Michael's uploading his slides, to all those who asked or who joined us late and what have you, because I know there was quite a few emails came into our info group as well, people who hadn't got the link and what have you. If you were late to join, we do record all of our presentations, and all of them get uploaded to our YouTube page at youtube.com/LIDNUG. This recording is no exception. Once we finish the session here and Michael and myself log off, we'll mix it into a proper video file and upload it. Now, depending on traffic and upload speed, sometimes it takes us a few hours, sometimes it's uploaded instantly. But the one thing I will say is, if you watch at LIDNUG on Twitter, or if you keep an eye on facebook.com/LIDNUG and or our Google Plus page, we will announce it on there once it's uploaded onto YouTube in some form or another.
Yep, and I'll retweet it.
And once again, thank you very much, Michael, and goodbye to everybody who attended. Thank you very much.
Bye, guys.